My name is Oscar. I work here at the Skyscanner as a software engineer. The team, I would say that it's platform security and automation, but I don't remember the whole name never. And I'm going to present using Pydantic for security static analysis of AWS CloudFormation files. I know that it's a very long name. But first I will introduce some things of Python. First I will introduce type annotations and data classes that you may already know, but just in case. And then we will jump to the core of the presentation, that it's Pydantic. And then we will finish with pycfmodel, that is what we built in a Skyscanner using Pydantic. And finally, what we have built on top of pycfmodel, and that it does the security static analysis. Type annotations. They were introduced in Python 3.5, and it's to help developers to know what's inside the variables. The important thing here, and the difference with other languages, is that Python doesn't enforce the type. So we will see with some examples that when we define a string, you can actually put inside an integer, and Python will not complain about this. This is an example that we can have in a function, and let me try. Yes. This is an example using a function, and this function has a parameter that we say that the parameter name is of type a string, and it will return a string. Here we can see that we pass, we call the function with goal, world, and we finally print hello world. After that, we have data classes. This is quite new, and this is a decorator that was introduced in Python 3.7, and helps adding special methods to the classes. You may have seen this as an example. I forgot a new line there. Well, you may have seen this, that it's a class where we need to initialize the class, and we have to implement all the methods to do comparisons with the object, and when we want to print the object and we want to have a special format like this. Data classes help us providing some default methods. Those default methods are the ones that we have to implement before, that are the init, the reference method, and the equals method. The data class decorator can also provide three more methods that are not default, but you can specify them, that are the order, that it can be used for sorting list of objects, safe cache, and frozen if you don't want the attribute to be edited or not. We can see an example that it's the same example that we have before, that it's the class person. In the previous example, we have defined the init, where we said that we have a property name and the property age. In this case, we just say that we have a class, we use the decorator data class, and using this decorator, Python will provide us the init and all the methods we had before to specify. So if we try to use that class, we can see that we use it as before, as a normal init, and we pass the name and the age. In this example, we can see that Python is not performing the data type validation, and it will return an instance of the class person with an age being a string when we said that was an integer. But Python doesn't complain about this, and it works. To try to solve that, we we have the Pydantic library that helps us solving this problem. And Pydantic provides us data type validation. We can, using Pydantic, we can define data property. It's a string or an integer, and if it doesn't match the type, it will raise a value error. We also have type hints at runtime with user-friendly errors. What does it mean? If we pass a property that doesn't match the type, Pydantic will say this property at this location and doesn't match the type. The third and the most important part is the recursive Pydantic models. And when we say recursive, it's imagine that we have the person object and we have a family. If we did a family with the decorator data class, the decorator data class will not check the type of the family, of the members of the family. But Pydantic can solve that. And also one of the most important parts of Pydantic is that it helps us creating custom data types that we can use. And when we use the normal data class decorator, we can specify the basic data types of Python, like integer, string, float, and all these things. But using Pydantic, we have a special checkers, like we can say a property that it's an email, and Pydantic will check if it matches the regex of an email. We can say that it's an IP, or we can say that it's almost anything that we can validate. It has a lot of validators for by default. So if we check again the example of the person, instead of using a decorator, we say that we want to inherit from the base model. Pydantic, it includes an option to use data classes from Python with some modifications that it can do. But this is we used to inherit from base model, that it's a special class that is created by Pydantic. We all say the name and the age like before, and let's see an example. Here we can see that we initialize a person instance, and we say name is J and age is 1. But now we are putting a try except to catch the validation error. This is important because Pydantic, it validates the type. In this case, as name it's a string and age it's an integer, we don't have any problem. But if we try to pass age and a string, we will see that Pydantic complains about this, and it says this nice error that we can use before yet. We can see that it says the model person has an error in the property age, and we have the message of that says the value is not a valid integer. Now we can see a recursive example. In this case, we have a family that we define a family to have a list of members. And we say that members is a list of persons. And all of this is implemented using the base model of Pydantic. In these cases, Pydantic will check if the person, if all the members of the list that we pass to the family are of type person, and when it does that, it also checks if every person complies the person's class requirements. Now we will jump to another example with a pizza, because everyone likes pizza. And in a pizza we have toppings. And toppings is a list of strings. It can be anything that we can put in a pizza, but we have a list of forbidden toppings. These forbidden topics, we can see here a new type, and this comes from the Python typing library. And class var, it says that it's a variable of the class. And we said that it's a variable of the class of type list, and the list, it has a string or several strings. We prohibit to having pineapples and kiwi, but we don't force that. We are Pydantic will only force that all the list, all the members of the list toppings to be a string, and we don't do any requirement. Actually, we can now put pineapple on the pizza and it won't complain. To solve that, Pydantic has a special decorator that is called validator. And with validator, we can define things or requirements that we want to make before the object is created. The first parameter is the property of the class that we want to check. And in this example, we say that the requirement is that doesn't contain forbidden toppings. As it's created, as the validator runs before the object creation, we pass the class and the value that we are going to validate. In this case, we say if the value that we are going to validate is inside the forbidden toppings, and we raise a value error. If not, we return the value. This is a cool example because validators run for each property of a class. But in this example, we can see that we have the modifier each item true. So when Pydantic detects a list or an object or a div, instead of passing all the object, we can say that only pass each value of the iteration. So in this case, as we have a list, each item, what it will do, it's passing each single item to the function and do the validation for each single item. Now, there is another example. This one is a little bit bigger. That this is another cool function of Pydantic. First, we have a class animal. The animal, we define that there is a static variable that is the type. And there is an instance variable that is also type. The difference is the value, sorry. And we add a validator. This validator checks the type. What we are going to do is to try creating objects and checking if the type is valid for each class. So we have a generic animal in case that we don't have a class for the animal, and we have those animals. We have a dog, and we say that the type value is a dog, cat, and we have the type value is a cat, and the same for octopus. So we create a zoo, and we say that we have a list of animals. In here, we say that animals can be a dog, a cat, an octopus, or a generic animal. If we go and we see an example, we'll see a cool thing of the how Pydantic tries to match a type. We create a zoo, and we say that animal can be an octopus, and it automatically creates an instance of the octopus class, and it passes the validation because we said that octopus was a valid instance, a valid class. And the same with cat, and finally we have a spider. And a spider, as we don't have any type, we say that it's of type generic. So if we run this, we can see that it creates an object that is a zoo with the animals and all the list of the animals. And we can see by default that all the types of each class has been fulfilled because of the type that we define here. for each class. And if we go one step further, we can see another cool thing of Pydantic. Pydantic allows us to parse and go objects from the dictionaries or YAML files if we passed previously to a dictionary. So we say that we have the class Joe, and we call them a static method parse object. With the parse object, we pass the property animals, and we set a list of dictionaries. Each list of dictionaries has the property type, and we define the same order as before. And we can see that a Pydantic automatically creates octopus, cat, generic animal, and dog instances. What Pydantic is doing is it grabs the first property that each animal, goes to the class and says, oh, animals, it can be a list of dogs, cat, octopus, and generic animals. So it goes in the same order, trying to create a class of its type. So for creating octopus, if we go back to the order, it will try to create a dog. And it will see that dog raises an error, because dog, it can be only when the type is dog. As it doesn't match the condition, it jumps to the next one. It tries with cat, and as it doesn't match, it goes to octopus. Octopus won't raise the condition of the class that is defined. It doesn't match the condition. So it will allow to create the octopus object, and it will be added to the list. The same happens with cat and a generic animal. Generic animal, what it does, and this is the reason because we have it in the last position, it's when we don't have any instance of an animal that we have defined before. So, in generic animal, the validator is a little bit different. What we do is we check that the value is not of one of the classes that we have defined before. If we try to create a dog, and Pydantic thinks that dog, it has to be a generic animal, so something on the data is wrong, because dog has his own class, and we have to create a dog with the dog with the class that the dog has. So if we end here, we have a very big problem. That's the reason, because we say we are instantiating a generic animal from a value that it's not allowed, and a spider doesn't have any special class for him, so we allow to create the generic animal. So we have all these cool things from Pydantic, and we implemented with all these things this library that is pycfmodel, that is a model representation in Python objects of CloudFormations. If you have worked with AWS, you may know that CloudFormation files are the files that you use to define cloud resources in AWS. For example, you can say, I want a EC2 instance that is a computer there and with that properties. Or I want a role that is running there and the role has some permissions. For example, in this case, we define a root role that we allow the role to have everything and to be assumed. So the role can be assumed by anyone in AWS, and it can do anything at any resource, which is pretty bad from the security perspective. So this is a code that I take a screenshot from the library, and we have a representation in Python objects using Pydantic of of few resources that AWS allows to create us. As we have with the spider and the animals, the spider was a generic animal because we don't have a special class for him. This is the same case. We define a class for each AWS resource that we can create, like this one. We say an S3 bucket policy. It has this type in the files. This is the type that you define on the files, and it tries to match each part of the file with an object. We have a resource that does the validation, and here we can see also the part from the recursive validation that Pydantic does. In the almost all the resources in AWS has a field properties. These properties that we define on top of each class are another Pydantic class, and we can perform validations there. So when a developer in Skyscanner uses that library, it can almost instantly know if their cloudformations are valid or not before going to AWS, because we are going to say, in this field, you have this problem and doesn't match this condition. And the reason because we build this is for building CFRipper. CFRipper was a tool that was made before data classes and everything. We have a lot of inits, and we're implemented using PyCfmodel and Pydantic, and allows us to do security checks against all these files. When a developer in Skyscanner pushes a cloudformation to AWS, and AWS takes the configuration and tries to create everything, before everything goes to AWS, we run CFRipper. And CFRipper creates a model in Python of the file, and if it fails to create the model, then it says to the developer, your model has this problem, so we don't wait to AWS to say this to us. And if it success to create the model and the model is valid, then we'll run a security analysis. The security analysis, it can be, well, this is an example of a rule. We can see here that we create a model. Model is the model that we created with the PyCfmodel, and we iterate over all the resources that are created by the PyCfmodel, by the cloudformation, and we run some rules. This is a rule that checks if the policy is attached to the group and not to a user, because it's bad that a user has his own policy attached to him. Well, actually, we have like 13 or 55 rules that does security checks, and we also have a command line that developers can use to run offline on their computers, and we can see here that they pass a template and the format of the output that we want, and we can see that this template is not valid because the rule, full wildcard principal rule, so this cloudformation, we said that has two security problems. One is that allows to do anything in any resource, and it can be assumed by any person in AWS. So CFRipper says that the full wildcard principal rule, the role that we are creating, the principal is an star, and this is bad because anyone can assume that role. And we also have an overprivileged role. So, the same role contains an star, and that star can be used to to access to any resource, which is also bad. So that's all.
Questions? Did you notice any kind of performance hits from the type checking? From the, like, if it's always running for every data class, like, is there any performance hits?
Actually, we haven't noticed that, but also we haven't checked it because we use that in purpose to do a validation of the model. Right. So we want to have the validation. We don't.
Right. So for a tool like this, it's great because it does the checking. Yeah. But on a bigger application, it might require more resources, right?
I would say so, but I don't have numbers to.
Okay.
I do have numbers about this. So Pydantic is one of the fastest deserialization engines in Python. So it's way faster than Marshmallow. That would be one of the alternatives that you have. In their web page, they actually have benchmarks, and it just blows them off. It's amazing.
Perfect. Thank you for the presentation.
Can you please open the slide when you fill your zero with octopus dog and cat? And so what would happen if you, for example, define two different classes like cat and dog, but the type value would be mammal, and you place that in your JSON or dictionary, which instance of class would be created?
If the type is inside one of the classes that are allowed, it will go there. If not, it will go to the last one that is the generic, and the generic matches anything.
No, I mean, it would be the conflict between two classes that have the same type value.
Okay, yeah. The first one that matches the condition from left to right on the list.
Yeah, so basically, I think that you do, it's really cool, but I think you mix two different things, like serializing and, data classes normally, as they are data transfer objects, normally we can use it for entities in domain-driven design, but does it really make sense? Does it really make sense to mix them? Because, okay, Marshmallow, it could be a bit not so fast, but it allows a lot of things like supports different types, datetime formatting, etc.
I would say that it works because we have the model validation, but yeah.
Also, one thing related to that, it actually does the date validation too, an email validation, an URL validation. It does a ton of things. It's just like a 30-minute talk. There's no time for everything.
Hi, do you know if it supports inheritance? Instead of saying that it's a list of dog, cat, octopus, you can just say it's a list of animals.
No, because what it will do is going here and it will say that value is not initialized and it will fail.
Okay, cool.
Thank you for the presentation. Could you go back to the pizza example?
To that?
Pizza example. In the forbidden topping, you write that you have a class var of list of strings. What if you have more than one list of strings? Can you exactly tell explicitly which list should be applied with the pineapple and the kiwi principle?
So you mean having a list of lists, or?
No. If you have two lists, like
forbidding toppings, veg, vegetarian.
Yeah, and they are the same type, and you're saying they cannot be a pineapple and a kiwi, but on the topping. And if you have other lists like I don't know, sauce ingredients, the pineapple and kiwi doesn't apply to this. How does the Pydantic knows that the forbidden topping, apart from the name of the variable, should be applied to the pizza topping variable?
I would say that you can create another validator and then specifying toppings, and Pydantic will go for each validator, and there I think you could do that, but I'm not sure. I would have to try.
Okay, thank you.
I wanted to ask if the list of rules that you have for CloudFormation is public in the repository.
Yeah, CFRipper and pycfmodel are open source. Actually, there are stickers of CFRipper on the table outside.
Cool. I think we can give Oscar an applause.